Mr. Eugen is starting the live stream. Da, 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 da. Ready? Are we live? Okay. Hello, everybody. Welcome to the meetup of two groups, PyMunich and PyLadies. I think people will be still arriving because I love the way how exotic people are picking how to get here. Some people get by S-Bahn, some by car, and some are cycling. Can you raise your hand who came by cycling? My God, look at that. That is impressive, huh? This is not Marienplatz. Well done, well done. We should get some prizes next time for this special activities. All right. Yeah, I mean, my co-organizer is a paraglider. Maybe I ask her next time to, take a shortcut. We sit in the highlight tower, so technically it's possible, I think, by kilometers, but I'm not sure she likes the idea. I will ask her on the break. Good. So today we have a first meetup that has more or less focused. So we always focus on Python. This is what our first talk is about. But today we are also focused on the AI and precisely RAG. Our speakers will give you better overview about that, about what exactly are the topics, and we will have a one big Q&A, which is sometimes called panel. We will see, we're experimenting what we do about this, but this is the plan. Our first talk is general Python. Our next two talks are about the AI, and we see what is the topic next time. There is no plan, we are improvising. I think that we owe a big thank you for the host, TNG, who is hosting us today. And as you see, there is still plenty of space over there. We are still expecting more people to come, maybe even more exotic transportation means, who knows, maybe some marathon from the center. You have shower here, by the way?
Yeah, I think so.
Can even rhyme, not a problem. Let's now give the words to Fabian from TNG to do the introduction and the first talk. And let's have some applause.
Yes, thank you very much for the nice introduction, and welcome to all of you to TNG in Unterföhring. The person who originally should do this introduction is unfortunately sick, and so I was asked yesterday to give a short intro on TNG, and I was asked, can you do that? And I said yes, because I'm a software consultant. So let's see, what do software consultants at TNG do? At TNG, we have a very easy mission, and that is to solve hard IT problems. We are a company that we call ourselves value-based. We have been around for 23 years now. We are great, that's why we have some awards. And very important, annually we have our big tech day coming up in July. If you're interested, please let us know and we can give you more details on that. And when I see such advertisement slides, I always ask, okay, they are value-based, what do they mean by value-based? Let me give you an example what my personal, one of the most important values to me is, and that is self-education. And that is actually why we are here today. So within TNG, we have about 850 people now, and we all share the common love for technology, and we do share the belief to educate ourselves in technology and always to try to keep up with things and to look into details. And that is why I was, for example, asked to give this talk here today and to have time to spend hours in the end on things that have no actually concern with my current project, but just to learn new things and to explore stuff. And that for myself is one of the key values that are important to me with TNG. Still, though, we need to earn money. We have clients in several branches. We have small startups, big companies, everything you can basically imagine, everything which has some IT could ask us for help. We are basically all software consultants, which as the name implies two things. We do develop software, we implement things, and we like to consult. And we do this on three main pillars. The first pillar that we do mainly is the classic agile software development. The second pillar is artificial intelligence, which, as you know, changed rapidly over the last years. I mean, this is also why we're here today. When I started in 2020 with TNG, it was already a big topic with TNG. At this time, deepfakes was the hot topic that TNG was working on internally as a showcase. And nowadays, we run our own LLM stack here in the basement, and I'm pretty proud of it. And it also gets more and more important for our clients. And then the third big area we are invested in is DevOps and cloud. So we bring everything into cloud, and we do this on our own, but we also consult our clients on that. So that's just to give you a really rough overview about TNG. We are here in Unterföhring. That's not that surprising. We love that you're here, and we wish you a very delightful evening. And that would be the part where I hand over to myself. So thank you for that. That's not my introduction slide. That is my introduction slide. Okay. So thank you, Fabian, for the nice introduction. You're welcome. Let's make Python the most awesome hello world. So that is not a reg topic, apparently. I was not told we have a theme today. And so I know what some of you might be thinking. You think, okay, now comes the guy who is just allowed to give a talk because his company paid for the pizza. And he will talk about his boring project where they use some Python. And that's it. And you're absolutely right. Except one thing, we have, of course, great projects within TNG. And because we are such an agile company, sometimes in the evening when we are on site, we sit together, have a drink. And then we still love to talk about technology. And recently, almost a true story, it happened to me that the colleagues more or less stated, well, I really don't see any reason to use anything else than Rust nowadays. It's all I need. And these situations, you know them, they are tough because it's not easy to react. And maybe it's not the time of the day where you can easily answer. Maybe you don't want to give an elaborate discussion now why there are big use cases for Python and other languages. What you're looking for in these moments is a simple answer. And the simple answer that I would like to give today is, well, Python has the best hello world. That would be great because, yeah, it's not the best answer, but for this time of the day, it would be sufficient to me. Just say it has the best hello world, and colleagues at desk, yeah, why? No, it's enough for me. Because this is, in the end, what we do all the time. We try a new language, try hello world, and that's it. So if that would be the best with Python, would be a strong argument. Is it the case? So here's the Python hello world that you all know. It's pretty cool. It's just print hello world. Yeah, what else do you want? I mean, Java is just ridiculous with that respect. Let's be honest. Forget about Java. JavaScript, nicer, although this console log thingy, okay, we know where it comes from. Rust, fairly nice as well, actually. I mean, you have a proper main function, yeah, this exclamation mark for the macro, okay, but it's nice. So yeah, we are ahead, but we are not that far ahead. Can we get better? That's our mission for today. Can we do better? Opinionated, true, but let's today we don't have that much time. Let's take my opinion. The best hello world to me looks like this: HW. Just HW, that's it. Could be a new thing. Hey, have you HW'd it? Great. So that is my best hello world. Can we do that in Python? Well, not exactly. Different ways to maybe cheat it, but it's not yet a part of Python. So my goal for today, can we make this hello world, just HW, be an integral part of Python, the best, most awesome hello world that we could imagine? Yes, we can do this. But how? How can we do this? Well, to approach this, first thing you have to understand, how does Python read our code, right? If I type HW in my Python interpreter, it will give me an error message, don't know what to do with that, right? So what does it do, actually? Well, the first thing it does with our code, it parses it, right? So for this, it uses the so-called PCHR, the parsing expression grammar generator, runs our code through it, and what comes out is a so-called abstract syntax tree. Abstract syntax tree is, there's nothing yet interpreted or anything, it's just a technical description in a graph form of our code. Let me give you an example. Let's look at the abstract syntax tree of our classic hello world. The nice thing, actually, when you ask a question, how does Python work? The nice thing about Python, I guess most of you know that, is that you can see everything from the top. So, for example, in Python, there's the built-in module, the AST module, the abstract syntax tree module, and I can just run here as parse, put in my print hello world string as my code, and what comes out is actually my abstract syntax tree. I can then use some third library to have a nice graph with rendering of it. And then this is the abstract syntax tree of my hello world. And we see we have here a module. In this module, there's a single expression. The expression is a function call. And this has to have a name, the name of the function, which is print, which has to be loaded, and a constant, which is the argument, which is the string hello world. So This is the abstract tree of our classic hello world. How do we get to an abstract syntax tree of our new hello world, the HW? How do we do that? Okay, we have now to get deep into insights. We have to go into the CPython. So what I did is a few weeks ago, I checked out the CPython repository, and I started to just hack in my hello world. First step, we have to add it to the grammar. There is in the CPython repository a file called Pythongram, which defines the Python grammar. And this is then understood by the regem parser in the end. So here you look through it, and then you find a section where it's about simple statements. And a simple statement, for example, something like pass or yield, assert, simple statements. And I thought, yeah, this is a good place for hello world. So let's put our HW right in there. HW is a simple statement now, and our parser understands. So HW is something, and it calls this magic C function, and that's it. And I thought, yeah, great, I have it. No, I don't have it. I can compile this. Oh, I have actually then to call some, I forgot this to mention, I have to call some, I don't see it this way. Unfortunate. I have to call some magic make function, which uses then this grammar file and creates some C files, some header files. And I thought, yeah, I have it. No, I don't have it. If I then compile this thing, Python, I get an error, undeclared function, Python hello world. Well, not surprising. And I was afraid, oh, my C times just some months ago is still anywhere. I don't want to do C code now. Do I have to do C code? No, I don't, because there's another definition file, the Python ASDL, the abstract syntax definition language, I think. So we haven't told that we have to add our hello world to the abstract syntax tree, and for this we have to define a node in our abstract syntax tree of the type hello world. And this I do by just saying, okay, here we can have, let's say, statement nodes, like a function def is a statement node and an async function def. And there I just thought, okay, that's a good place for my hello world to go in. So I defined here a hello world s node. And then again, I call some magic make function, which basically templates some code. A fun fact, by the way, which language would you use to template code, to render templates? You would use Python. And interestingly, if you call this make function many, many times, it's just a Python call. So Python generates its own code, which is interesting. And a nice fun fact, by the way. So we are there. Then I admit, if I compile this, I get some warnings. Actually, I have to do some minor C tweaks, but not that important. But in the end, that's all I have to do. And here we have it. Here we have our HW abstract syntax tree. And this is really code that I ran with my Python version. So I again have my AST imported. I pass just HW, and I use this third Py library to render my tree, and I get this tree out. And I have just a module, and in this module, a single statement, which is our simple hello world expression. That's it. And that's nice. And now I could actually open my Python console, and I could type HW, and nothing happens, which is a good thing at this point, because I also don't get an error anymore. I don't get an error, but it's not what I wanted. I wanted the best hello world. So how to do that? So what we did so far is we told Python HW is a word you understand, and it's a abstract node that you understand. But then Python says, okay, what should I do with it, right? So what we then need to do is we need to compile it. Interesting fun fact. Second thing, maybe one thing to take away from this talk is when you ever get ask the question, is Python a compiled language? Well, don't say no, because you've been here and you know better. It's just wrong. It's not no. But don't say yes, because you don't want to get into this discussion. Just change the topic. Anyway, we have to compile it. So what does it mean to compile Python code? What happens to our abstract syntax tree after we have gotten it? So we are there. We have the abstract syntax tree. We also have a symbol table, which I skipped for the sake of time for today. And these things then get put together. And what Python then does in its compile step, it builds the so-called basic blocks out of it. A basic block is like, you can imagine as a single piece of code of instructions that have a single entry point and possibly multiple output points. So for example, an if statement, I have a single entry point and I have branches where I can go out. And this defines my so-called CFG, the control flow graph, which is basically just how Python then runs through the code later on. And then this graph gets assembled, so it gets more or less squashed together, meaning I squash this graph into a line of blocks, and everywhere where I have to jump, I put in a goto statement, more or less. And what comes out is a so-called code object. And the code object contains all the code instructions. It contains variable names, constants, possibly nested code objects. Maybe a little hard to understand now what this is. Again, the nice thing is we can look at this code object right from Python itself. So let's look at the code object that we get for our classic hello world. Again, I can just use native Python code. So in Python, if you haven't seen it, there's a built-in compile function. I can call this compile print hello world statement. I have to put in some metadata, which is not important for us. And I get a code object, which for us today has three main parts. It has the code, it has some name and const. And this code we see here is what you might have heard of, hopefully the famous bytecode. Bytecode is a sequence of bytes, not that surprisingly. And most of the time, it's a sequence of 2 bytes. First byte is an operator and an opcode. And the second byte is the argument to the opcode, most of the times. Problem, we don't quite understand this string. It's hard to read, so we don't know what 97 is for an opcode. Fortunately, there's a helper tool for this. There's the disassembly module. And you can just dis the code object, and it prints you out a nicely form of your bytecode, which is nothing else than the bytecode we saw before. We have always here the opcode, so we have an opcode for resume, and then the argument. And here in the first column, just have the line where it started, so line 0 is nothing, and then everything else is in line 1. And here is the point in the byte sequence, so the index of the byte we're looking at. And so what we, for example, see here, we have an opcode load name. The argument is 0, which means load the 0th name that you have in the name list. The name list, remember, is just a tuple with a single entry, so this name is print, and so that I don't have to go back all the time. It also tells me, okay, this is print. And then we load a constant. The 0th constant is hello world. And because in Python, everything returns, at the end, we load a constant, which is the first constant, which is none, and return this. And this is essentially what bytecode is. Not too complicated, however, not what we want. Now we have an idea, okay, what can we do now? We need, of course, naturally an own opcode for our best hello world. It should be an integral part of Python, so let's build our own opcode for hello world. Not that difficult, although we're actually in C code, or almost C code. So here I'm in the file bytecodes.c, which actually has not been around that many versions as far as I know. And here I just add some inst statement where I say, okay, I want to have a new opcode, which I call hello world operation with actually no arguments or nothing. And if that is evaluated, we'll come to this later if I have time left. If that is evaluated, let's call a magic hello world function, which I didn't code myself, but asked ChatGPT and just inserted it via some header file into the C file. Again, I do this. This is actually not the actual C file that's used by Python. Then again, you don't see it, but I run some magic Python make comments, and I get compiled, rendered some nice C files. And there's my hello world operation. Problem, of course, there's still a link missing between my hello world opcode and the est hello world node, so the past Python code. So let's do this. For this, we go into Python compile C, the compile file where the compile function more or less lives. And in this compile function, you see a compiler visit statement function, which visits all the est nodes, the nodes of our abstract syntax tree, and kind of decides, okay, what should I do with it? And here we say, okay, if the kind of node you are dealing with is of hello world kind. Again, this hello world kind is not written by me. It's like generated by this generator calls. If you happen to get to a hello world kind node, then return some result of a compiler hello world function, which I wrote here. And this is quite simple. It says, okay, if you have a hello world statement, then just add an opcode hello world at the line where you currently are. That's it. I just add this opcode to this point. Maybe I'd explain an example. So I've done this. I've compiled Python, and that's it. So I can now actually compile my HW statement. Again, some metadata, and I see here, well, this resume test is the default thing, and I have just my hello world operation and the default return const statement at the end, and that's it. And since I have 2 minutes left, let's talk about what happens next, just to get some understanding of that maybe, or some hope. What then happens is, well, if you start Python, what happens is your interpreter gets set up. We have interpreter state, usually 1, maybe more, containing all the modules that are loaded per default, the built-in names, and so on. And this points to a list of thread states, which are pretty much linked one-to-one to an actual operating system thread of yours, keeping track of tracebacks and so on. And then, importantly, in each of these thread states, there is a stack of frame objects. And these are the objects that contain these code objects and then are worked on one after another. And in this frame object, there's two important stacks which are important to just notice. There's a value stack, more or less working as the heap in your computer would do. And there's a block stack, which keeps track of the blocks, like a with block or a for loop, for example, which is then unwinded when you leave a block. So in order that when you put somewhere a break statement and Python would like to know, okay, where am I? It looks where I'm in this block stack. And these kind of stacks are really maybe that's why I'm talking so much about that. These are one of the reasons you can really think of the Python interpreter also as a virtual machine, because it really has the things that a normal virtual machine has. It has like kind of registries, it has these stacks. It really works as a virtual machine. So also don't discuss this, but just that you know. Yeah, and that's how Python works. And then as this frame object, which is evaluating all the bytecode operations. And then at the end, this is how I imagine it comes to a big giant switch case, in C, and this switches over all the different opcodes there are. So I say I have here opcode x16, and here the argument, please handle it. And this, just also that you have heard it, is the point in time where the famous global interpreter lock comes in place. So for those who haven't heard this, right now, at the end still, it's up to discussion right now as far as I know. Python is actually single-threaded in a way that every thread that is executed first needs to gain this global interpreter lock, and this is the time where this is checked. And this is how Python then works. So, and this is the time now. I have 1 minute left just to show that. Kept the introduction short. This reason to show you how does now our best hello world look like. So let's see whether this works now. I have here just a normal console. And I am in my repository that I checked out and manipulated. So in the CPython repository, is that Python exe on a Mac, which is weird, but this is how it's compiled by default. I'm here in Python. It's some alpha version of 3.14 that I checked out on June 12th, apparently. No, that's today, right? I compiled it on June 12th yesterday. But I checked out 3 weeks ago. And yeah, let's see. Interesting moment. Here it is. Isn't that the best hello world you ever could imagine? Isn't it great? Yeah, and actually, that's all from my side. So thank you very much. Okay.
Another round of applause just for that last piece. Let's have questions. Hello, thanks for your talk. What was the focus? To understand how Python works, or there was something deeper behind, maybe, I don't know, modify Python specific purposes, I don't know, for your project or something like that?
The main purpose was that I have fun doing this. To be honest, I had a similar talk prepared a few years ago, and all my colleagues know this already, so they're quite bored. And we researched for someone who could give a Python talk today, and I said, yeah, sure, because I'm a software consultant. And then I thought, but I don't have the time now, and I thought I can just recycle the old one. But then I thought, okay, I need to spice a little bit up, and then I came up with this. Would it be great to have the best hello world? But yeah, I don't think we should add this as a PEP.
Thank you. And I see one more question.
Maybe we should. Let's discuss later.
Maybe kind of a stupid question. Program compared to a conventional print hello world program in a benchmark.
Good luck. That's a good one.
The mean thing is, I had the same question, and I wanted to do a benchmark, but I hadn't have the time. So I would expect it to be slightly faster, but not that much, because the main overhead goes into all the. It also depends whether you do the measurement inside your interpreter or you always start the interpreter new, because all this coming up with the state and everything, that's where we lose a lot of time for such a hello world thing. If you would do it inside Python, really in a for loop, let's say, and measure that, I would expect to be slightly faster.
Okay, more questions. Well, the tricky one, really, like to keep our speaker in shape. The tricky question. Yes, yes. I know you can do that. Here you go.
How did you make the important engineering decision of introducing a new bytecode for your hello world syntax
as opposed to having your syntax to generate a sequence using the already existing bytecode?
Well, the honest answer is given by him because I wanted to do so, and I thought it has more learning effect. Yeah, that's the answer. I'm sorry. There's and it's slightly faster. I mentioned for this answer. Maybe we could spare a millisecond on that. Maybe.
Cool. Okay, then if there are no more questions, are you sure that there are no more questions? No, there are no more questions. Let's make a selfie before the next talk. Great. Cool, thank you. Then another applause, please. We do one more talk straight away, and then we will have a bigger break. This is usually better because I hate to kick you back from the break. I want to make a bigger one instead of back and forth. So let's see how this works. Microphone? Yeah.
Oh, sorry. Too many mics.
Yeah, too many. You are important. That's why. Mic 1.
Okay, test.
Mic 2. Good. Like a boss.
Okay.
Okay, so let me introduce Nithish. Nithish is our old friend, and he's organizer of PyData, or was, or still are. Are you?
Yes.
Good. So check out PyData meetup as well. It's a good one. But today we will be talking about RAG. And this will be the introduction, and the next talk is also about RAG. So let's see where it gets us. Okay, please applause for Nithish.
Hi, everyone. Thanks for the introduction, Anton. Today in this talk, I'm going to basically cover what RAGs are. And then the next talk is also going to be about RAG, and then hopefully we can take some questions. So just a few notes about me. So my background is mostly data and machine learning engineering. And right now I work as a developer advocate at Couchbase. For those of you who are not familiar with Couchbase, it's a document database quite similar to MongoDB, except that we have a different architecture. More focused on high performance workloads. And right now, what I do is I build like integrations with all the developer ecosystem. What this means is if you have heard of all these LLM frameworks like LangChain or Llama Index, those kind of things. So basically, I work on building all these integrations that support Couchbase with them. And as Anton mentioned, I'm also the organizer of PyData Munich. And if you'd like to talk about Python, please reach out. So before we go into RAGs, there are a lot of these AI tools that came up over the last year or year and a half. So these days, everything is getting powered by AI. And by AI, it's more like these large language models by all these big companies. So you have like ChatGPT, you have Gemini, you have like Llama 3, you have even like all these specific things like from this stable diffusion models from Stability AI, you have Midjourney for image generation, you have like coding assistants from GitHub, like all those kind of things. I mean, these days, every company has to support, has to have like assistants that use AI to support users. And so with that, we come to the first question. Can you use LLMs for your use case? And like, unless it's a really like stable and well-developed ecosystem with a lot of data that is publicly available, the answer is no. Like, for example, this was like something that I just asked ChatGPT, like this 4O model, to just generate a LangChain app using Couchbase vector store. And like the application doesn't even make sense. So it's just hallucinating, coming up with some random things. And this is not just the case with like less popular, let's say, or like newer things like the Couchbase vector store. Like if you remember last year, like AWS had this AWS Q, which was also quite received like a lot of negative feedback, especially from like this guy like Corey Quinn, who is like quite popular at like making fun of AWS. But essentially, like, I mean, the problem is like AIs, all these large language models, they are not, they tend to have like these hallucinations. They come up with things that are quite like, if you take a look at it, like at first glance it looks like it would work, but it just never works. And you waste a lot of time if you are just trying to debug this. Yeah. And you also have a lot of these knowledge cutoffs, like for example OpenAI. It's, yeah, I mean, all their models have like a different cutoff, and anything after that, it just doesn't work. And that's where we come into the concept of rags. I mean, so there are like other solutions as well out there. So for example, you have the option to fine tune these large language models, where you provide your custom data, and it's like transfer learning, where you uh, basically provide like this custom data for your use case to it, and then basically the model learns from it and gets, it should be better for that use case. However, the problem is you need like a bit of expertise. It's not as simple as just uh, providing some data. And I mean, like with this, all these GPU availability issues and all those things, it's quite expensive. Like, I mean, if you are using something like OpenAI, they have an option where you can provide data and do this fine tuning, and they serve it for you. It's a bit more expensive than the normal uh, OpenAI APIs, but yeah, I mean, you cannot always guarantee that the results are accurate, and it's, you need a bit of expertise for it. And like the other thing is like the RAG, or like retrieval augmented generation, which is, I mean, this comment is from like Jerry Liu, who is the basically the creator of Llama Index. He termed RAG as a hack to make LLM works for you. So essentially what you're trying to do is like you are injecting your custom data into the LLM context. And I mean, I'll just go through the next slide, which will explain it a bit better. So what is retrieval augmented generation? So essentially what you're trying to do is you have a corpus of your data for your use case, which is not part of the LLM. And this, so essentially whenever you ask a question, you fetch data from this external source uh, using something commonly known as like vector search. So vector search is like pretty common. Like essentially you do like a semantic search. It's not an exact match. It's like things that are similar. So it's using like an embedding model which maps all this relationship uh, between the different terms, or like, yeah, terms in the corpus. And you have this information that is there in your vector store. So you get that information, and then you provide that information to your LLM as part of the context for the LLM to basically generate an answer for you. And this works quite well quite well, I would say. I mean, based on whatever I've seen. Yeah. And I mean, for those of you who are not familiar, so there are like a lot of LLM frameworks out there. What these, so these are like a couple of most popular ones. On the left, or yeah, on the left you have LangChain, and on the right you have Llama Index. But essentially what all these LLM frameworks allow you to do is they allow you to create like LLM powered applications in a much easier, or like in a mix and match format. So for example, you can use any model and combine it with any vector store. You can also load data from a bunch of sources. It could be like PDFs, or it could be like S3, or it could be Notion or Slack. I mean, there's pretty much like people have built like integrations for most of the data providers there. Yeah, Jira, Confluence, you name it. And Llama Index is also quite similar. I mean, personally, there's a little bit of difference, but for the most part, the functionality is like similar across both of them. And for this example, I'll just use LangChain, but essentially we have examples using Llama Index as well, if you're interested. So this is like the typical RAG workflow that you have. So you have your raw data, It could be any source, like I mentioned. It could be PDFs, Docs, Slack, Confluence, you name it. You you then basically load this document, and you also need to do like a bit of fine tuning. So by fine tuning, what do I mean? It's like the feature engineering in the classical machine learning. So you need your data to be clean so that you have the right context for your LLM. I mean, even if it's not like perfectly clean, it still works because, yeah, I mean, these models are like pretty good at it. And so what you have is you have your data that you use like these document loaders, and then when you load them, you generate the embeddings, and you can put it into any vector store. So here, just Couchbase is just a placeholder, but you can replace it with any vector store, and there are like many of them, including like things that are built on top of SQLite and Postgres, like you name it. Everyone has it. And then uh, what happens is like when you have your user input, it goes through, you generate like embeddings for it, and then you fetch things from your vector store that are like similar to your user input, and then these are provided to your generative AI app, and these are injected into the context, and you get your response back from the LLM. I mean, this is like enough theory. Now let's go into some demo applications where it becomes a bit more clear. Oops. Oh, yeah. Okay. So this is like one of the classical examples where you have uh, like a document that you can feed with. Uh, so this is like just a simple chat application where you can provide like a PDF, and basically I do chunk these documents, like because your documents can be arbitrary length, and you don't want like the context to be too high. I mean, right now for most of the LLMs, the context is not that big of an issue, but still it reduces the cost, not having to send like a million tokens. Yeah, I mean, for this example, I'll just use like documentation. So this is like the Couchbase vector store that was just updated last week. And yeah, I mean, I just basically took a print of it, and I'll just upload it. Yeah. So, I mean, it takes a few seconds because, like, yeah, you can see that the document was split into 20 different documents. And if I go to my database and do like a fetch, you will see all the documents. So right now, this is like the text in the document, and you have an embedding, which is basically the vector representation of the text. And you have some metadata associated with it as well. And yeah. So now with this, you can actually ask things like, okay, how can I use Couchbase vector store a LangChain application? I mean, here, like what I've done is like I've done like two different answers. So one is using the RAG approach, and the other one is using the pure LLM. And in this case, I'm using just OpenAI GPT-4o. And as you can see, like in the first RAG use case, you get like the answer which is right, because this is like exactly what is in the documentation. Whereas with this LLM use case, it tries to like basically create this Couchbase vector store. I mean, this would work, but it's just like quite rudimentary, I would say. So you need to do a lot more to create like this Couchbase vector store. And yeah, yes, better. Yeah. So, I mean, this is basically all this thing was possible because you got the right documents from your vector store that you could pass to the LLM. And this kind of works. I mean, whereas in the other one, yeah, I mean, it just tries to come up with some random code which doesn't make sense. I mean, I can also show you the code. I mean, it's not a lot of code. And yeah, I mean, staying with the traditions. So here I have like a Streamlit application, like which was covered, I guess, in the last two meetups. So yeah, I mean, essentially all that you have is like a Couchbase vector store where you provide like information about the collection, which is like the table where you want to store. And I mean, the interesting piece of code is here. So so here you have this temp like prompt, and then this is like basically this LangChain uh, expression language where you provide like a prompt, and you can also specify the LLM and like how you want to format everything. And like this retriever, if you look at it, it's like the vector store. So what this means is you want to fetch, so you want to pass the question to the retriever and pass it into the context of the prompt. Yeah. And like in the other case, you just have the question and you have a prompt without like the context. I mean, for all practical cases, this is like a F string in Python. It's just like their way of doing it. And yeah, I mean, there are like some good things about it. I mean, maybe not here. It's probably not the best use case for it, but like in some, like in the next demo, I can show you a bit more complex use case. And the rest is just basically streaming the response from the LLM. And like there's one more thing that I want. Yeah, I mean, here's where I split the documents. So here I have like a chunk size of 1,500 characters with like a overlap of 150 characters. Yeah, I mean, now I have like another small demo. So this is like a bit more like complicated. So here what I've done is like, we have this Couchbase documentation. It's like public documentation. And what I've done is like, I've basically scraped all those pages and put it into a vector store. The idea is that you can chat with the Couchbase documentation. So you can ask questions and get answers. I mean, yeah, that's the idea. And like, for example, I mean, let's start with maybe a basic question. What is Couchbase? Because like most people are not that familiar with it. Yes. Yeah. I mean, so here you get like an answer, and you also get like, I mean, some links to the documentation with more information. Now, let's say, how can I connect to Couchbase via Python? And yeah, here you get like a bit more, like get an answer. I mean, all these answers are from the documentation. And yeah, I mean, here you can see like, if you look at it, this is basically the same code. So all this is coming from the RAG application, because otherwise you would get like some random answer. I mean, this is mostly because the way LLMs are trained, and also, I mean, our documentation is probably not the highest priority for the LLM, and that's why it happens. I mean, you can also ask follow-up questions, right? So I get an unambiguous timeout exception. How can I handle it? Yeah, I mean, this would also tell you like, yeah, I mean, to increase like the timeout, I guess. Yeah. And there is like some more information about how to do it. I mean, now I'll show you something which tells you how this whole thing works under the hood. So this is like a service called Langsmith. It's basically observability for your LLM application. I mean, it tells you at all these individual steps in the LangChain expression, let's say, what is happening. For example, in the first case, you had like, what is Couchbase? And then you basically have this retriever, which is basically fetching 4 different documents from the vector store that are relevant to this query. And like, yeah, I mean, here you can see like maybe not all of them are relevant, but like at least 3 of them are relevant. And then you have, yeah, and then, yeah, just, yeah, yes, sorry. Yeah. And then here you have like, you have the prompt, and you can see that the context is all the documents. And yeah, and yeah, let me just, and here you get like the response from, yeah, like you have this whole thing like introduction. This is basically all the documents from the vector store. And here you can see that the documents are probably not the best in terms of the formatting. Like there are like lots of things that could be removed from the pages, like this footer and stuff, but it still kind of works. And like if you look at the next thing, so the next question was like, how can I connect to Couchbase via Python? And like here you had like a, so what is happening under the hood is you want to, so you could send the entire context back to the OpenAI, but then you send a lot of tokens, and like it's not the most efficient way. So what this application does is it tries to summarize the existing conversation and then sends that as like this, uses that to retrieve the documents from the vector store that are relevant. And then, so here you can see that, so this is basically the conversation, and it is trying, just asking it to get the query. And here you can see that connect to Couchbase using Python. And then you get like, you send that to your vector store, and you get like some documents that are relevant, and then you send it to the LLM. And here you have the answer. And in the last conversation, you can see like, yeah, I mean, here you can see that the question was, I get an unambiguous timeout exception. But you can see that due to the summary, you have like things like Couchbase, Python SDK, and ambiguous timeout exception handling, and you get like all these documents. Yeah. Yeah, and then you basically do the same thing, and you get like the answer from the LLM. Yeah, I mean, I can also show the code, but this code is a bit more involved because there's like multiple chains here. So for example, yeah, here you have like this query transformation, which is basically converting all this message history into a single query. Yeah. And what else? Yeah, you also have like a bit of message history. Yeah, but this is like a bit more like it takes a bit more time before you can like understand this like whole thing. I mean, there like the langsmith helps a lot. And if you look at this ingestion script, this is like quite straightforward. You have like a file with all those URLs, and I'm just using Beautiful Soap to load those documents. Yeah, I think, yeah, I'm nearly done. Yeah, I mean, you have the links to all those demos, like, yeah, all of them are like public. Yeah, and there's even some tutorials. And if you want to use Couchbase for it, you have like Capella, which is our cloud managed version of Couchbase. Yeah, there's a free trial if you want to try. Yeah, that's it.
Well done, Nithish. Applause, applause, applause. And traditional selfie.
Yeah.
Good. Questions?
Yes.
Why did you do this?
So yeah, I'm also working a lot with LLMs,
Mhm.
with stuff. That's why I have two questions. First about Couchbase, I never used it.
Mhm.
What are your major features? And you have hybrid search, quantization, so on. Like, if you know more, tell us.
Yeah. Yeah. I mean, so Couchbase is basically a document database. It's so, I mean, if you are familiar with MongoDB, it's quite similar in terms of functionality, but like we have a different architecture. So it's like there's no master slave architecture. So you can write to any node in the cluster. And so that's why people, I mean, we have a lot of people who come from Mongo because their performance is not good enough. I mean, that's where like the use case comes. Like if you have a high high volume workload, that's where Couchbase works in. I mean, in terms of vector store, like what we have is hybrid search. Yes, we do support hybrid search. And we have like all these integrations with all these frameworks like Llama Index and LangChain. I mean, we are working on some more performance improvements. Right now, it's you can combine it with full text search, so that's also something we have. And you have like eventing if you want to generate embeddings on the fly, meaning like you. So at the end of the day, we started from like Memcache, so it's like a pretty good caching solution. So that's where it started. So you have like really low latency reads, so like 5 to 10 milliseconds.
About preservation, analysis, images, audio.
Yeah, I mean, right now we don't support that. Yeah, I mean, this is something we are considering, but it's not right now. It's not part.
Another question is about your Rack. So you implemented it for them. Did you do regulation?
Yes, I mean, so that's always kind of tricky. I mean, so the thing is, there are two parts of it. So one is, I mean, we tried using Ragas for like some basic evaluation, but I wouldn't say it's like completely scientific. I mean, it's just like what we did was like we had like some like real world answers or like real answers and then tried to compare it. But I mean, we don't, so what we're trying to do right now is like try to work on like a more public version of this solution, in which case we need to have a bit more checks and balances.
Rack is statistical metrics, voting,
Yeah.
variance. Have you tried ice from Stanford?
No.
It was smaller models to scoring.
No, we haven't. But this is something that we are like quite exploring it, because we are trying to get this into the like this some of these AI assistants, and then we need, if this has to be public, we need to have better information about.
You can use semantic chunking, I guess. About some automate.
Yeah.
Thanks.
Thank you. Oh, okay. So there will be a bigger Q&A after the second talk. This is just about the talk and probably about Couchbase. So here you go.
Thank you for the talk. Very interesting introduction to the Rack system. I have a technical question about sourcing. You showed one example where your LLM also put some sources where did it found.
Yeah.
How does it exactly work? Because if I understand correctly, if I put like one big document with my documentation, then it's maybe like 100 pages. And if you perform an embedding here, the only thing you get is a vector, which has like a semantic meaning of all of this documentation, but you lose the information. Where is it exactly? Is it then possible to source where did the LLM find this information? Like for this, it's on the page number 18. I found this function. How does it work?
Yeah. So in this example, like what I've done is like I've chunked the document. So you have like this 100-page document, and I think it's like done, I think at a page level. So this is also something that you get out of the box from LangChain and Llama Index. So they provide like, if they provide like this metadata, which tells you which page this document originated from. And then basically you can get this as part of your vector search result. And then you basically parse it and put it into the output. And that's how it is done. It's, kind of low tech.
Well done. Okay, one more question over there. Please pass the microphone.
Thanks for the nice talk. Just a quick question on Couchbase. Can you also run it locally to store your vector store locally, like with Llama Index? And if so, how do those two, for example, compare?
So you can definitely run it locally. So right now, vector search is part of like this enterprise edition. It is still like free. You can use it for like trial use cases without doing anything. But like if you want to go to production with it, you need to pay for the license, but you can run it on your data center. So we have both the cloud and like on-prem version. In terms of comparison with ChromaDB, I mean, I've done like some tests, but I don't have like real like hard numbers or anything. I mean, from what I've seen results are relevant, like kind of similarly for both ChromaDB and Couchbase, and also like Mongo, Astra, Pinecone. Like basically, since I wanted to have a way to see if what I'm doing is right, I basically did like a single script that tests all the results, and I found all of them to be quite similar. Yeah.
Good. There were more questions. Hold on, there was Mr. Terminator raising the hand, please. Can you put your glasses back?
Yeah, there we go. They're way bit concerned. Anyway, my dude, great talk. Thanks so much. I was wondering, so a lot of this relies on the whole rack system, right? Relies on this the embedding space, right? As in, yeah, finding good entries depends on the distances of things in embedding space being close to each other. Are there pushes in this direction? Because I keep seeing, custom similarity and sort of the same embedding models. Is this something that maybe you guys are pursuing, or something that you've heard about and stuff, that where it's going, kind of?
Yeah. I mean, that's a good question.
I mean, you have to answer now.
Yeah, I mean, personally, like I've basically tried like some of these open models from Hugging Face. I mean, these things work quite well, but like something that quite interested me was this Matryoshka models, like embedding models, where basically it's like a high dimension embedding vector, but you can also do like partial searches, and it still would make sense, like how all these Matryoshka dolls fit into each other. I mean, so that was quite interesting. But I mean, as Couchbase, I don't think we are doing anything right now.
Okay, there was a question here.
Thank you for the talk. Just a short question. Can you use RAG for pictures?
I mean, technically, it depends on the model, right? Like the embedding model. So if your embedding model supports images as well, you get images that are relevant to your search term. But I mean, does it make sense? Yeah, that's something depending on the use case, I would say. Yeah.
Good. I think we are through with questions for now. Save some for later, because Mai will be the next speaker. By the way, do you agree with everything he said?
Yes, we can talk later about it.
So I feel something in the air. Okay, there will be an interesting break. Okay, then let me finally use this and let you have some break. Okay. 15 minutes. Or 10. Or 5. Danny, how long? 20. 15.
Thank you. Okay. Thank you. Yes.
Maybe you can remove.
Oh, sorry. I didn't realize that. Oh. Anton, you need to help me with this.
So what was wrong? What was wrong?
No,
You will probably talk about it, right? This whole
evaluation.
and evaluation.
Are we back?
We are back.
Good, we are back. Our next talk is also about RAG. And let me introduce Mai, our speaker. Are you from PyLadies group? Actually?
Yes, PyLadies.
From PyLadies,
I'm
yes.
very happy to meet ladies here.
Representing PyLadies, yeah. I'm not sure what's the ratio today of PyLadies and PyMunich. Looks normal to me with my usual meetups. But anyway, yeah, I think that it is good that we do these meetups together. We also used to do meetups with PyData group with Nithish, so maybe we do that in the future as well. Will be even more huge. Good, so please make some warm welcome for Mai and her talk about RAG applications with Phoenix.
Thank you. Thank you. So test, okay, works. Thank you very much. Thanks TNG also for hosting this meetup and PyLadies for inviting me today. I'd like to attach to Nithish's talk. So he already introduced to you Retrieval Augmented Generation. And I want to talk about the evaluation part. So when you develop such applications, what do you need to consider and how do you actually evaluate them? Shortly about myself, I'm a machine learning engineer at Inovex. We're an IT project house spread all over Germany. And in my free time, I'm a coach for children with migration background, and I also coach girls regarding the chances and risks of AI. At Inovex, we are writing RAG applications for our customers. And I'd like to give a high-level overview about the components, just a recap to what already Nithish has introduced you to. So when we have a RAG application, it could be, for example, a chatbot, there's a user asking a question via a UI. It could be Slack, Teams, or any customized UI. And with that question, the UI transfers this to a kind of orchestrator. Nithish has already introduced to you, for example, LangChain or Llama Index. And this orchestrator gives the question to the knowledge base. So in our knowledge base, we keep domain data. That's the data from company, metadata from company. It could contain, for example, contact names in a company. It could contain medical data or contracts data. And this domain data is stored in a somewhat semantic store that we do with embedding models. So these are pre-trained models that vectorize your data in a space so that similar data are vectorized closer to each other and dissimilar data are more apart from each other. And with the knowledge base, we are collecting relevant documents from our question. And these documents you can see here, we call them context. And when we have the query, the use of questions and the context, we are querying the LLM. Yeah, the LLM could be, for example, OpenAI's GPTs, it could be Llama or any other LLM. And the LLM is pre-trained, right? So we are sending the query with the context to the LLM, and the LLM generates an answer to us that is given back to the orchestrator, which gives it back to the UI and displays it to the user again. And we do this in order to cheaply query our domain data without the necessity to retrain our own LLM, for example. And when we develop such applications at Inovex, we have faced some challenges. We wanted to know how our application actually works and how we can improve with that. And these challenges I'd like to highlight on this slide again. And it starts actually at the user level. So when the user is asking a question, how do we actually formulate our prompts? So you've heard from prompt engineering, the discipline of constructing your prompt, making it clear and concise, the way of how to talk to LLMs in order to get the best out of it. And you can already improve a lot here, but I don't think this is the main pain point of our applications. One more thing to think about after the orchestrator is the retrieval part. So when you actually ask your knowledge base, what documents fit to that query? You're asking, for example, I need contact persons for department XYZ. It maybe queries the internal documentation of the company and gives back like 10 pages that could be relevant for these contacts. And the science here is that you actually retrieve the relevant pages from a big data source, but also maybe the re-ranking part. So with some of you, I've talked about it. When you have 10 documents, how do you rank them in a specific way so that you give them further to the LLM? Then the data part, how do you process it the right way and how do you chunk your data? So when you have domain data, be it Confluence pages, be it PDF files, JSON files, or code, the way of processing them and bringing them into small chunks so that they are relevant to your query is actually a hard topic, because these documents can contain formats that are not easy, right? You can have papers with diagrams, you can have Confluence pages with tables, and based on, depending on your use case, you have to decide how to best process these data and chunking them. The embedding represents your data in a semantic space. You need to find the best embedding model for your use case. That depends, of course, on the field you are in, but also on the language, which restricts you in the first place anyways. When you have your data stored, embedded, and the orchestrator retrieves the data, we are sending question and context to the LLM. And this is where prompt templates come in play. Prompt templates are some kind of guidance to the LLM of how to talk to them. This sounds pretty trivial in the beginning, but every LLM is actually trained in a different way. So you are talking to OpenAI's models a lot differently than to open source models like Llama or to smaller models. And you need to find out the best way of how to interact with them and how to give the content with the query to this LLM in order to get the best answer and to take the most of the model's capabilities. So this is just a few sets of pain points that I have observed in the past months. This is definitely not complete, but I'd like to address some of them in the following slides. And I do this, you want to take a picture of this? Great. And I do this with 3 clusters. So we start with observability, asking how does our application actually work. So we're going to talk about prompting, we're going to talk about responses. So what are users asking, what do we get back? Then we're going to talk about evaluation. So not only how does it work, but is it even working correctly? We're going to talk about matrices that align with the retrieval and the data processing. And at the end, this is a niche feature. I shortly want to go into the inference analysis. So how does our data is actually stored in its semantic space and what can we put as a consequence from that? And before we dive into these 3 clusters, I want to introduce you to the tool that we've used. It's called Phoenix. Phoenix is an open source AI observability platform from Arise AI. And it's one of many platforms. So there are so many alternatives on the market, but I really like this tool because it offers a lot of integration. So it's easily integrated in LangChain, it's easily integrated in Llama Index. It has integrations for LLMs like OpenAI, Bedrock, Llama, Vortex, etc. And it offers a very, very nice set of tools for implementing and evaluation. I mostly like the setup of Phoenix. I have to change anything in my code. I did not have to change my chains at all. The only thing I need to do is to define an inferencer in the beginning, and I can easily roll it out containerized or even in a notebook for experiments. So this is Phoenix, and I'd like to go into these 3 clusters now. So starting from observability. So what our rack system is actually doing. For that, I have a demo. But something happened to me that never happened to me before in a presentation. The server is down, but I am prepared. I will show you a demo delayed. And what you can see here is the Phoenix platform. So you can see a lot of lines here. They are called traces, and each trace will show one user query at a time. You see the user query at the input here, and it's not working. And the output in the 4th column here. When we click at one of these traces, you get a detailed view. So what Nithish has already shown in the LangSmith. So LangSmith is also an alternative, but tightly coupled to LangChain. Arise Phoenix not. And you can see detailed like the input data again and the output to that question. What is also attached are, for example, the retrieval part. For every input, you can see which documents have been retrieved from the knowledge base and the data for these documents. You have the ID, you have the content of these documents, and some scores. which means the relevance regarding to the query. And what I actually really like is that you have a very nice overview of all the traces. Here you also, this will go a bit further. You also have in the header some metadata, so how many traces you have, how many tokens, so how costly it was until now, and some metadata regarding performance. So the observability shows us in a great way of what is actually asked, how does our application work in production. Then I'd like to quickly talk about the matrix of RAG. So right now, when we see what is asked, we want to actually find out how well did it perform. And for this, Phoenix offers some metrics. They are not complete, definitely. They are a good starter, I think. We have mentioned Ragas before. So Ragas is a very popular tool for generating synthetic data and offers also a lot of metrics for that. So faithfulness, context precision, etc. And you can integrate other metrics in Phoenix as well. But Phoenix offers these kind of matrices. So we separate them in two parts. We have the response evaluation and the retrieval evaluation. The response evaluation focuses on if I pose a question, does my answer actually align with it regarding to the context. So we have the QA correctness. That means does the answer is correct to the query with the context I got. Then hallucination. Can the do we detect a hallucinating LLM response relevant in relation to the content we got? And is the response of the LLM actually somehow racist or biased, for example? And then there are metrics for the retrieval. So how relevant was my context that I retrieved, and how can I go further with that? And for this, you can see here, we have in the evaluation column here an overview for every trace and the labels. So QA correctness too much, for example, is incorrect, but you also see that it's hallucinated. And for the retrieval part, you can see the relevant scores as well. Yeah, when we have a look deeper into the retrieval part, you can see that there are the scores attached to every document themselves, and then they are also summarized. What Phoenix also offers is that you also get some kind of explanations for these metrics. And you can guess that this is done by an LLM as well. So it's automated by an LLM, and usually you use a smarter LLM for the judgment of the generator LLM. In this case, we use GPT 3.5 Turbo for the generation and GPT-4 for the judgment. And then this is a niche feature of Phoenix. I have not seen any framework that offers a visualization like this. They offer an inference analysis. It's in order to understand the semantic representation of your data. So what you have is that every prompt and every response is embedded, right? You have a vector for every sentence that you got and is saved in your database, and the responses and prompts, they are grouped in clusters. And in this way, you can find out very well how well your prompt in production aligns with the corpus you actually have in your database. So is there something totally outlying? Are your users asking actually the right questions to your corpus, or do you need to enrich it? And the term embedding drift comes also in play here. A drift means that there's a change in data. So language can change over time, images can change over time. And we use this embedding drift in order to detect if the prompts in the production actually drift away from the data we've seen so far. Maybe I can show this because this is not. Yeah, okay. I'm trying it. So what you see here is that you see embeddings. I hope it's big enough for you, and some dimensions. And when you click into that, you actually see an embedding space of Phoenix. Yeah, blue is the primary, so that means the queries that has been posed, and gray is the corpus, so what is seen in your database. And we have used this because in the project that I've been recently worked on is that we tried a lot of different models, and we needed to find out which model fits the best to our data. And in this way, you can find, do the queries actually are found in the space of the corpus or not? And what is actually really nice is that Phoenix offers these clusters. So if you click, for example, in one of the clusters here, you find some details about it. You can also click on the single points as well. And if you open one details of this, you find everything that belongs to this. So the prompt, the response, and all the dimensions, and even the documents that has been retrieved from that prompt. I think that these inference analysis helps you to give an overview about how well it fits to your use case, and if you need a model switch, for example, or not, or if you need to have some middle steps in your pipeline. So far, so good to Phoenix. So we have looked at observability, we have looked at evaluation and inference analysis, and I would like to give some key takeaways. So observability seems at the beginning maybe accompanying your system, but I think it's especially valuable when you go into production and you want to have a look at what your users actually want and what do they need. It fits very well to beta testing, at least it did for us. And every use case is different, so you need to find your pain points. I had projects where prompting was a bigger issue than processing data, for example. And other projects where we have been processing tables with complex information, and we used most of our times actually for processing them in order to the LLM to understand what is standing in these tables actually. And then at the end, I would highly suggest not to only rely on the metrics itself. LLM accuracy does not mean that it's relevant to the business. Always sit together with business stakeholder and find out what is actually important for them and align the matrix, the automatically generated matrix, with what the use case actually needs. Then this would be it from my side. Thank you very much for your attention.
Thank you.
Oh, I'm sure we will have questions. So let's do straight like this, because there will be many questions. So I'll just put some chairs, and you can address questions for this talk, but also questions for RAG in general. Nithish, join.
How do we do it with the mics?
Well, you'll have to fight for that.
So, hand over.
Don't be shy, it's okay.
Okay, fine.
Okay, so I think it will be fair to start 2 questions for this talk. So, yes, of course.
Thanks for your talk. I'm curious about your LLM, because I know that Phoenix, you use binary classification approach as part of LLM attached for metrics like toxicity and others that you showed. Are you satisfied with that? How do you feel like it works or not for your use cases?
So in the project that I've been working on, we have used smaller LLMs for generation. And so we have wanted to try to use OpenAI for LLM as a judge, and Llama as well. Llama were quite okay, actually, Llama 3, but we made the best results with OpenAI. And for now, we have not used Phoenix as a 100% influence in our judgments. We use it for accompanying it. So we tightly work together with our stakeholders, bring these results to them, and we discuss it with them. So it's actually like a base for our discussion, but it's not a final decision.
Yeah. Okay. Continue this topic as a judge. You used it only for RAG, but have you tried to use it for, I don't know, system level or end-to-end? Usually you have some business metrics, and you generate some replies, and they should follow some quality standards like issue recognition, consolidation, whatever. Have you tried to employ LLM judge to this level end-to-end?
Actually, not yet. So our projects are actually in this phase. So we have implemented RAG brought retrieval into production and evaluating it right now. But we will definitely keep it actually in mind.
And you mentioned that you haven't seen other tools that support clustering visualization, like parallel nodes, Aporia.
How it's called?
Aporia.
Oh yeah, okay. Don't know that one. Yeah, I think the market offers so many frameworks, but I'm always open actually to try out some. Does it also offer the other features that Phoenix offers? The matrix and observability visualization?
I tried several tools, basic comparison.
Yeah.
And non-complex selection one, but I can disclose what the selection.
Okay, excellent. Yeah, maybe we can talk in the break about it. I'll be very happy.
And have you tried Iris framework? I asked previous speaker as well, but also asked you, it's standard framework that uses smaller transforming models for the scoring.
Which one?
Iris.
No, actually not. We have used actually the bigger ones before, yeah. But interesting insights. Maybe we can share some.
Okay, do we have more questions? Of course we do. Who is the next one? Yes.
Well, thanks again for the great presentation. I have a question regarding this whole workflow in order to set up the brain, because you have so many moving parts, like which LLM, what is the right chunk size, what is the right embedding, what is the right size of the embedding. Have you found any way to automate that? Because then you also have to generate the examples, and it's very tedious. When it's very tedious and a lot of manual work, and some way, I mean, I cannot stop thinking that this must be easy to automate one way or the other. Is there any tool that you have found?
Actually, we just start with one. I think one key point is to actually set up a platform like this in order to trace what you have done and what worked well. But what we always do at inovex is to exchange regularly about the databases we use, the models we've used. I don't think that you always need the biggest model for every use case. I have to admit, I don't like to use GPT for every use case. That's why I've set this up. So we have been working with smaller models so far, with open source models, and set up observability platforms in order to trace. But I think depending on your field, so if you're working in the German field, you have automatically less choices for embeddings. There you're already restricted. But in the English field, you also have like the big names that always work well. Would you agree?
Yeah. Yeah. I mean, so it's kind of similar, like all these platforms or like frameworks like Llama Index and LangChain do is they make it easy for you to swap out all these components.
Yeah.
I mean,
true.
Yeah, I mean, it's kind of similar for us as well. Like we just try, most of the times we just use whatever is like easy to get started with. And then if the results are not good or if there are some more specifications that come up, then we just switch it up.
But one thing, because you have mentioned LangChain and Llama Index, we have talked about LLM frameworks. So they have a specific focus. When you want to start small, I'd recommend more Haystack for small POCs. If you want to have complex applications that are going to scale, you can use LangChain. If your application focuses on retrieval, then Llama Index is maybe the right choice for you. I would start always small and go bigger.
Thank you. Next one. Here you go.
Was wondering, both of you have again accumulated experience now on testing a lot of components and combinations and such. Considering, especially when taking, say, sort of more or less vanilla parameters, more or less, the bigger, more performant models, how much variation do you see? Right? Are we talking about, okay, if you pick the optimum, you're like 10 times better, or is your customer 10 times happier, kind of thing, with the selection, or is it more like little optimizations? Because like I have no idea, right? Like given that you've scanned a bit the parameter space a bit more.
So this depends again, I would say. So I had use cases where you work on data with sensors, for example, or on data contracts from real estate or so, where factuality is very important and where you need maybe a stronger model. But when it's more about information extraction from PDFs with tutorials or something, you don't need the best model for that. So I'd say it depends on the use case and also the way how you put it into production. You always have like a small circle that you work first with, stakeholder first, then a small beta test circle, and then you go big. That's what I would suggest.
Yeah, I mean, so in our case, most of what I do is like internal tooling. So I mean, these are used by other stakeholders inside the company, and so basically we get like some feedback from them whether this is like more or less right or what they expect, and then just basically go from there. Thank you.
Thank you. Oh, we are just getting started, just warming up, I feel.
Thanks. Maybe more specific question for how you organize your data. And sometimes it's worthwhile, you know, to make page summaries, and then you on the page, and then you go into the different chunks of the page. And sometimes you just take the whole document because you say, well, attention span is so wide that you can feed the whole document into it, but only if you really need it. How do you manage that trade-off, and how do you go about designing this architecture that's needed for your particular use case?
Yes, so I mean, like from my side, like most of the times it's a trial and error. Like you need to try a few things and see what happens. I mean, what makes a difference. Because, yeah, I mean, personally, I think it's better to reduce the context as much as possible. And I mean, even though like all these newer models, they have 1 million tokens or 2 million tokens in their context window, it's still like there are some papers that are doing some research and studies on these, and I mean, it's still like debatable whether you want to do it. So, I mean, what we tried, or like what I personally try to do is like reduce the context as much as possible by like doing all these different things like semantic, like chunking, or all, or like just by different like context sizes, and then see what makes the most difference. I mean, like have like a short test set and try to see if we can find something.
Yeah, there are data where the some parts of the documents depend on each other. For example, in a paper, right, the introduction depends on the main, etc. And then there are data where you can actually handle them in a separate way. And this is something that I think you need to consider when you chunk. Yeah, so one more addition.
Good, good. Is it a question or is it the answer?
I can share also my experience. So it's chunking the data, especially if you use some details and structure a lot of tables, you can suppose the pattern, you want to use it in your cases. So actually it's better, like if you have tables, you need to maybe exclude merge cells, for example, to duplicate data instead. Maybe instead of table, it's better to get a description of table. You can use like generate description maybe automatically. There are vision models now. You can use vision models instead of images tables and use generate descriptions instead of real data. It's also quite interesting. And if you have some structured documents, I mean, some set of headers, for example, several levels, some paragraphs, you can join your headers together with paragraphs because they bring more concepts that might be used. Of course, like this was said, there is so-called semantic chunking that just understands where to put this, that checks sequentially of sentences. If chunk distance, I mean semantic distance between sentences is not so high, it just joins together sentences in a single chunk. Or there are hierarchical chunking that just like tree-like structure for chunks, and you, instead of extracting one chunk, you can extract upper level parent, for example, that gives you more context than just single low level sentence or something like that.
Yeah, and maybe to the context size, more context size. As if you give more data, it doesn't mean that the LLM treats it all equally. Maybe it just listens to the data that you give in the beginning or the end, but loses the information in the middle. So I would focus more on quality than quantity. Yeah.
Thank you. I'm doing a big technological upgrade because people online asked, and we love all of our participants online or offline. So this is a state-of-the-art device which combines in-person and streaming. Look. Here we go. Next question. Thank you. Thank you. Next question over here. Please, you are free to be the first one to use this technological breakthrough.
I will do my best. Okay. So I liked your approach, like LLM as a judge, but I have a question. Did you do some evaluation for this approach, like some metric or human base, and how did you evaluate your retrieved documents or information for this to say the LLM was better than as a human?
Thanks for this question. So Telecom has published a data set, I think 2 months ago, where they have questions and answers and human labeled judges. This is the only data set until now that I know is of this size. And we use this in order to compare 2 models. So I told you we were restricted in the model choice for the generation, and we could generate actually some accuracies with that. Yeah, so far. Did you make some?
I mean, so one thing we do is like we have some data that we collect. Basically, these are like for example, we have like this integration like with VS Code, for example, where you can ask it to generate like SQL queries. And so there we have like some queries that are generated, and we have like a user feedback where the user can say, okay, this is right or wrong, and they can also add like comments. I mean, right now we just collect it, and the idea is that once we have a better model, we use this as like a training or like evaluation set.
Next one.
Could you like have the right answer and then the generated answer, and then embed them both, and then have like a numeric distance, so to speak, of the answers? Did you try that?
I mean, we haven't tried it, but yes, you can do that. I mean, the question is, I mean, it's still like kind of the semantic distance, right? I mean, it doesn't mean that like, I mean, how could you interpret it? Like interpretation is kind of hard, right? In this case.
Because if you have the same sentence, the difference only with not, distance can be 0.8 quite high. So you still can like the opposite, like paper, because of not, but they will be semantically close. But semantic distance is not enough.
Yes, for factuality.
I can see eyes full of questions. Who will be the next one? Then I will be the next one, and we still have online some questions. How much time do we have left? Okay, then I just take my chances.
Sure.
Okay, next is we speak mostly about text generation in this context. How about images and video? Does it applies the same way or no?
I think there is the most need on the market for text because it just brings fast, big value, I'd say.
Text can be in the image as well.
Yes, actually, so as you said, technically, you can embed images. You can compare these images, right?
Yeah.
And how you judge them would be interesting. Yes.
Yeah. I mean, so like one thing that we've tried is like just to have like a demo where you do like both images and text on the same, using the same embedding model. So they are all in the same space. I mean, technically, you can get images as well as text that are relevant to your query based on semantics similarity. But I mean, it depends on the use case at the end of the day.
Right.
Yeah, I mean, this was just like movies. So you get like posters. So you take the posters and just do like a embedding from it, and you also have the synopsis. So the idea was that you get like movies that are based on the description of the image or like the synopsis.
Okay. Okay. To extend that, like text in this case is kind of a source for the question. The channels through which the question is prompt is inserted. Could we replace it with a video? Imagine we're making a video assistant or something like that. What are the technologies and research state in this direction?
Yeah, I mean, I think like there are all these OpenAI, you can chat with it, right? I mean, so I think they also have a video one, but I'm not sure. But definitely you can do text. I mean, text, not text, images.
Mm-hmm.
So, I mean, technically you can break down the video into images and then do some kind of like summary or like, yeah, I mean, do some kind of concept. Like you need to reduce it and then use it to basically do some kind of vector search or like LLM. I mean,
This model, just like vision model,
Yeah.
recognize from each frame, get textual description, and then use it. Write summaries, whatever.
Yeah.
We have
Yeah, I think this was what like Windows, like Microsoft just launched and got like a lot of criticism.
next question over here.
Yeah, no, it was more of a, I guess, kind of question, kind of challenge the statement of, yeah, like how to interpret these when you embed, yeah, these multimodal embeddings. I pose the statement that I think a lot of it is more than limited by the needs of the customer. In this particular case, is limited by the quality of the models. I think that multimodal models are actually still lagging massively behind, right? And again, maybe you all know more about this, right? That there's just much more pressure for the document space versus the document space being just the one that works much better, that's actually much closer to what one would expect in production, versus these other models that exactly you experiment with them and it looks neat, but beyond that, you run into exactly, yeah, just performance issues, like something you wouldn't trust to have in your production, be it for vector search, so embedding spaces to search for video and text jointly, or for even the multimodal LLMs, right?
Ha ha ha. More questions. More answers. All right, let me check if we have anything here. Oh, we do. You've shown interesting technical stack. What would you recommend to a beginner to just try RAG out? Anything open source, freely available?
As I mentioned, I'm actually a big fan of Haystack. Haystack was my first LLM framework that I've used. It's very lightweight, intuitive. It had an upgrade just recently. And I think if you build small use cases, go for that. Go for this, go for, yeah, the integrations are big. Actually, you can find a lot of LLMs you can use, open source LLMs, some local database that you can start with, Elasticsearch, or any else. Yeah.
Cool.
And yeah, that would be my suggestion. If you want to go further, then I would go over to LangChain.
Yeah, I mean, LangChain is good, but probably Llama Index is a bit easier to get started with. I mean, it has like a lot of defaults out of the box. I mean, it does like RAG out of the box. Like that's what it comes out. Like, I mean, it's harder to do vector search with Llama Index than RAG. So probably Llama Index.
Okay. I saw some recommendation here. Like, you are the most active participant, perhaps. We don't have a prize. Like a souffleur, would be nice to put some box here.
I can just add, like, to start, it's really, there are great courses, short courses, but by deep learning AI. So they're available for free still because beta testing. And the great thing, you have access to some models. And Andrew Eng, he has a lot of courses on RAG, on just how to start with LLMs, and you have access to GPT 3.5 Turbo mostly. So a very good place to start, I would say.
Thanks for the point, though.
Okay, this is a final chance to ask a question. Even a stupid one, because everybody started, it doesn't matter anymore. No. No, okay. No stupid people among us. Of course. Then a big thanks to our speakers.
Thank you. You can always approach us now. If you
Yes,
want.
yes. So we are about to close the meetup. We have some questions now to the hosts. How long can we stay? Okay, then till it lasts. Good. This is the first part. So the plan. We continue to chat and network. Now we still have beer over there, so let's not waste it. Let's have a good use for that. The first thing. Then the second thing is from us, the meetup organizers. We need more speakers. We see your active crowd. You are engaged. Share. Sharing is caring. So we have a formal way and informal way to become a speaker. The formal is the sheet over there where you can put your name. And informal is talk to me or talk to Danny or talk to Eugen. By the way, I think they deserve an applause. Can you stand up, please? Our co-organizers. They are shy. And now he cannot even get out of that trap of cables and cameras and everything. You have to jump. That's what it takes to be an organizer. Yes, so we need speakers. It has to be about Python. But now we take the next challenge and we try to make focused meetups, which makes it even harder. Like you saw, it went well today, I think, to have like not really a focus, but at least a direction in where like we try to schedule our talks the way that for every meetup we have some kind of a direction to be discussed. So yeah, we do need speakers. In fact, we desperately need speakers because we are doing a lot of meetups, as you have seen. Yeah, speaking of which, when is the next one? August 22nd confirmed, and we might make one more in July, but this is not yet confirmed. And why it is not yet confirmed is because it's damn hard to find host, especially such a nice host as here at TNG, where we have a lot of space, all of the toys and bells and whistles. So we are not as demanding, actually. We just need enough space to fit our meetup, which you know the scale yourself. If you work at a company who is interested in hosting the meetup, please talk to us as well, also formal and informal way. Yeah, we want to have even more meetups, and we have pretty good tempo right now, which is forcing us to be more active in the search for hosts for July, and then the next one will be, I think, already in November. Yeah, this is the second topic. Third topic and the final one, we are all Python developers in this room. Well, not really all, but most of us are Python developers, and we want to share also. I heard during this chat that some people are looking for jobs, some people are looking for people to hire. So we want to connect you. We don't take a commission for that. It's free. What we want, we as Tech5, as organizers, are projects. We're always interested in cooperation, in doing some work for other cool companies in Munich. And we have this network of meetup that we are not really HR, so we are not good at selling this. And we want to help, especially this situation on the market, like many people are getting laid off. I know that. They talk to me, but I have really nobody to match them against. And our company right now is also not hiring that actively, to be honest. So please talk to me about this as well. As I say, there is no commission. Just if you need Pythonists, talk to me. If you are looking for a job, talk to me, and I'll do my best to connect all of you. Good. So thanks a lot. And let's finish that beer.
I would like to host you at inovex, but we have limited capacity, like 50, 60 people.
50, 60 is good, because in summer months is...
Yeah, maybe when, you actually plan less people. We would love to welcome you, really. I'm here 12 minutes apart.
Good. We need Danny to write down. Do I have your contact? I do.